Hi there, welcome to another video on digital electronics. So today what we are going to see is we are going to see supposed to borrow, right? You are supposed to borrow. Remember, this is in the base of 2. So when you are going to borrow, you are going to borrow in the base of 2. That is how you will be doing in a normal decimal subtraction also. You will be borrowing the base 10. So now I'm going to borrow the base 2 over here. I could not borrow because it is 0. Again here it is 0. I could not borrow. So everywhere it becomes 1. And except here it becomes 2. If I'm going to subtract 2 minus 1, it is 1. And all the rest is 0 for me. So now I have done my subtraction. So I have got a positive sign number. So I don't have any negative sign number. So if I try to convert this back to decimal, I would be getting the value 17, which is the correct answer. So now for this case, there is no issues. I can do a normal subtraction by this way also. But what happens if I change it? That is 112 minus 129. What happens if I change the value? Now I'm going to do the other way. What happens if I change 112 with, now I'm going to do what? Now I'm going to take 112. So 112 is 1, 1, 1 followed by 1 followed by 4 zeros. And 129, it is a decimal number. When I convert that to a binary number, it is 1 followed by 3 zeros, again followed by 3 zeros, and I have 1 over here. So now I'm going to subtract this. So as you know, we can't subtract 0 minus 1, so I have to borrow from here, right? So now this becomes 2, this becomes 1, this becomes 1, this becomes 1, this becomes 0, this becomes, right? You have already borrowed. Now what would be the value over here? Now this has to be borrowed, right? I have borrowed and now I have to borrow again. Now what happens over here? Now there is a weird kind of a situation. So I have an answer over here, 1, 1, 1, 1, which is not at all minus 17. I should get minus 17. How do I get minus 17 if I'm going to have all 4 ones over here? So now my problem goes wrong. So I have a problem. So now how do I do it? How do I solve it? That is where 1's complement and 2's complement come into place. Right? So the condition is, if you know how to add two binary number, that is enough to do a subtraction also. Now let us see how this is done. So now we are going to go to the next topic, which is I'm going to do the same using 1's complement and 2's complement. Now you found the difficulty when we do a normal subtraction, right? Borrowing, right? Borrowing becomes a difficult task for us. So now I'm going to do the same by doing 1's complement. So 1's complement, so I'll take the same number 129, which is a decimal number. I'm going to subtract with 112. I'm going to see whether I get a positive 17 results over here. So these are all decimal values. So now let us see how to do it in 1's complement. So I'm going to focus on 1's complement. So the procedure is, you have to do a complement of your subtractor. So this is your subtractor, this is your subtrahend. So take the complement of the subtractor and add with the subtrahend. Right, that's all. 1's complement, add with the subtrahend, and what the result you get determines whether it is a positive number or a negative number. Now let us see how this goes. Right, now 121, so the binary value of 121 is, we have already discussed. I am writing it once again. So it is 1 0 0 0 0 0 0 followed by 1. And then the binary value of 112 is 1 1 1 followed by 0. The first step in 1's complement is, now you have to take the 1's complement of this subtractor. 1's complement, that is, you have to do the complement of this subtractor. What is meant by complement is, convert the 1's into zeros. But before doing that, what you have to do is, you have to make sure that the weight of both the digits are same. See here, what do you mean by weight is, what is the how many bits are there, right? This is 1 2 3 4 5 6 7 8. So we have 8 bits. But what do we have here in 112? We have only 7. So it is not even. So we have to make it even. So in order to make it even, what will be is, we'll be appending a 0 at the front. So any zeros you put at the front, that is not going to make a big deal. So now what we are going to do is, we are going to subtract. So now, as usual, take the complement of the subtractor, convert all the 1 to zeros and 0 to 1. So now it is 0 over here. So I'm going to convert this 0 to 1, and I'm going to convert this 1 to 0, 1 to 0, 1 to 0, and we have 4 zeros over here. So it turns out to be 4 1. And now what this is the complement of 112, right? This is the complement of 112. Now what I have to do, I have to add this 112 with 129. For ease of purpose, I am writing 112 again, right? 112 again, and I am going to add these two. So if I am going to add these two, what will be the result? So 1 plus 1 is 10, right? 1 plus 1 is 10, where 0 is the sum and 1 is the carry. So I'll put the sum over here and carry over here. Again 1 plus 1 is 0, carry 1. 1 plus 1 is 0, carry 1. 1 plus 1 is 0, carry 1. And 1 plus 0 is 1. So we don't have anything over here. But if you add over here, 1 plus 1 is 0 and you have a carry 1. When you have a carry 1 in 1's complement, what do you mean is, you have a positive number. The result is positive. So if the result is positive, what you are going to do is, you are going to add this 1 to your least significant bit. You are going to add this 1 to your least significant bit, right? This 1 is added over here. So now what you will get the result? 1 0 0 0 1 0 0 0. So did we get 17? Yes. So if you convert the binary number back to its decimal number, you get a positive 17 as your answer. So we got this. So this is just addition. If you know how to do addition, we can complete this. Now the trickiest part, right? What happens if so I'll just do it for understanding purpose nearby itself. So I'm going to do so that you can understand what is the difference. So now I'm going to do the ulta, right? What is the ulta is, I'm going to subtract 112 minus 129. So I should be getting minus 17. This should be my answer, right? So we'll see how this is achieved. So as usual, the subtractor should be complemented once. So what is the subtractor? 129. We know what is 129, right? So we know what is 129. I'm going to take this 129 and then I'm going to complement this once. So 0, 1, 1, 1, and again I have 1, 1, 1 followed by a 0. This is the complement of 129. This is the complement of 129. So now I'm going to add 112 to it. So 112 is 0, 1, 1, 1, 0, 0, 0, 0. And I'm going to add both. If I add it, 0, 1, 0 plus 1 is 1, 0 plus 1 is 1, 1 plus 1 is 0, carry 1. We have 1 plus 1 as 0, 1 0 you have, and again you have a carry. So if I add it, we get 1 1. So 1 is the sum, this one would be the sum, this one would be the carry. So 1 is the sum and 1 is the carry. Again the same condition applies, 1 is the sum and 1 is the carry. Now you see you don't have any carry. When you don't have any carry, now this is a negative number. You have to remember this. In one's complement, if you don't have any carry, it is a negative number. When you get a negative number, what you have to do is, you have to do the complement of this particular answer. The complement of this answer is, just convert 1 to 0 and 0 to 1. So if you convert this, it will be 0, 0, 1, 0, 0, 0 and 1. So now you get 17, but you have to get minus symbol over here. That's all the ones complement is. Now this is the one way to do the complementing of data. So this is one way to do it, a subtraction, right? The other way is the 2's complement. Now let us see how do we do 2's complement also. So now 2's complement. So this 2's complement is the widely used method all over the world. So I'll take the same example and try to convert, try to do 2's complement also. So the same as 129, that is 129 minus 112. The answer we get is 17 as the positive number. So how do we do the 2's complement? So as usual, what you're going to do is you're going to convert that into a binary number. So 129 stands for 1 0 0 0 0 0 0 1. This is 129, and 112 stands for 1 1 1 0 0 0 0. So first condition, check for the weight. If it is not equal, balance it. So I'm going to put a 0 over here. So now this is your subtrahend, this is your subtractor. So the important part, 2's complement. Do the 2's complement for the subtractor. What is 2's complement is, add 1 to the least significant bit. That's all. Complement the subtractor and add 1 to the least significant bit. So this is your subtractor, right? This is your subtractor. Complement this once. So if I complement it once, I'm going to write it over here. So I'll convert all the zeros to 1 and 1s to 0. So first would be 1 0 0 0 1 1 1 1. Then what you are going to do is you are going to add 1 to the least significant bit. So 1 plus 1 is 0, carry 1. 1 plus 1 is 1 0, 0, carry 1, 0, carry 1, 0, carry 1, and you have 0 0 and 1. So this is the 2's complement of your subtractor. Now what we are going to do is you are going to add this 2's complement subtractor with your subtrahend. You are going to add this. So for ease of understanding purpose, I am writing the 129 as it is. and then I'm going to take this value. This is 1 0 0 1 0 0 0 0. Now I'm going to add these two. So if I add these two, I get 1 0 0 0 1 0 0, and 1 plus 1 is 0, carry 1. If I get a carry, right, if I get a carry, then the result is a positive number. If the result is positive, just discard the carry. The resultant would be your answer, which is 70. Very simple, right? Just discard this answer if it is a positive number. Now, we'll do the other way. What happens if I change the data? That is 112 minus 129. So what happens if I change the value? If I'm sure that I'm going to get a negative answer, so I'm going to change this. So now the task is we have to subtract 112, which is a smaller number, with 129. So I'm supposed to get minus 70, right? This should be the answer I should be getting. So 112. So we have 0 1 1 1 0 0 0 0. So now what I'm going to do is this is 112 for me. So I have to do the 2's complement for 129. So 129, the binary value. First you have to do the binary value. First you have to take the binary value. So take the binary value of 129. Then complement it once. So it would become 0 1 1 1 1 1 1 0. Then add 1. This is the procedure to take the 2's complement. Now we have 1 1 1. 0 plus 1 is 1. Again 1 1 1 1 1 1 and 0. Right. So what is this? This is the complement, and this is the value that you have got. This is the value that you have converted from 1 to 9, and this is the complement value of 129. And by adding 1, you got the 2's complement. Now what you are going to do? You are going to take this value, and add it with 112. So now what I'm going to do? I'm going to add it. Let us see what would be the change happening. So 0 plus 1 1, 0 plus 1 1, 0 plus 1 1, 0 plus 1 1, 1 plus 1 0, carry 1, 1 plus 1 is 1 0. You have 1 0, and then you have this carry also. So we're going to add this, so it will be 1 1. So I have 1 and 1, the same condition, 1 and 1. See here, you don't get any carry. When you don't get a carry, it is a negative number, right? You have to understand that. If you don't get a carry, it is a negative number. If you don't get a carry, what you have to do is you have to take the 2's complement of the answer. So 2's complement of the answer is convert the answer with the complement. So complement to this and add 1 to the LSB, least significant. Right? Now you got the answer. So when you are writing the answer, it is denoted as